Welcome to section 5.2, factoring trinomials. Okay, so once again, trinomials, if you recall, are the polynomials that have how many terms? 3. 1, 2, 3. And we're working on trying to factor these. So that means we're trying to rewrite it basically as a multiplication problem. So here's a question. What is the connection between factoring a trinomial and FOIL, which we learned before? Let's take a look. So let's use this example here. X plus 3 times x minus 5. We know how to FOIL this, right? To multiply it out. So right now, it's currently a multiplication problem. To FOIL, we'll go ahead and multiply the first to the first, so we'll get x squared. And then first outside, so negative 5x, inside 3x, and then the last two, negative 15. Okay, so let's go ahead and color code that. So the last two, the product, or the multiplication, gave me that end. And then what else do we have? Well, we have the 3x and the 5x. Okay, so simplifying this, we'll end up with x squared. We can simplify these two and we'll get negative 2x minus 15. And then we have a trinomial. So what is the connection? Well, the connection is when we FOIL, we end up with a trinomial. When we factor a trinomial, we want to end up with this product. So if I was to factor that trinomial, I would want to end up with a product. But if I FOIL that multiplication problem, I'll end up with a trinomial. So they're basically opposite directions of each other. Now the question is, how do we factor? Well, if you'll notice, the last term, the negative 15, where did it come from? It came from, let me back up here, wrong color. It came from the last two terms being multiplied together. And then the other question is, where does that negative 2x come from? That comes from the O term, so the outside, and the inside term, the O and the I, and adding them together. Okay, so that knowledge on how we do that is how we're going to go ahead and practice factoring as we go along. Okay, so just keep that in mind. I'll explain it a little further. Example 1, factoring polynomials when the second degree term is a positive 1. So notice, if you'll take a look at all these, they all have a positive 1 coefficient for the squared term. That's the easiest one to factor, because you don't have to worry about the first term. So let's take a look at the first one. You'll recall the end term should be a product that, when I actually add those two together, the 3 and the negative 5, for example, I should get the middle term. So what we're looking for is factors of 30 that when I add them together, I'll get a negative 1. Okay, let's take a look here. Factors of 30. Let's go ahead and write out the pairs. We have 1 and 30. 1 and 30. We have 2 and 15. We have 3 and 10. We have 5 and 6. And then we would have 6 and 5. So that's it, we're done. So these are the possible choices we have. And we got that from 30. Now the next thing we want to do is figure out the signs that our factored form should have. Okay, so once again, this is what our factored form should look like. It should be two binomials, like we had up above in the beginning. We want to figure out what the sign should be. So the end sign comes from when you multiply these two signs together, the two middle ones. So how would you end up with a negative number? The only way to get a negative when you're multiplying is to have a positive and a negative. Okay. And then, since we have a negative x, we know that the bigger number should be the negative. Okay, so let's take a look at these two. When I subtract them, which one gives me a negative 1? That would give me 29. That would give me 13. 3 minus 10, or 10 minus 3, that would still not give me a negative 1. Ooh, but 5 and 6. If I subtract them, I'll get a 1. Remember, I'm trying to get that 1 there with that 1x. But then the question is, which one should be the negative, the 5 or the 6? Well, since I want a negative 1, I'm going to go ahead and give the 6 the negative and the 5 the positive. And since we only have the x squared term with a positive 1, we'll just go ahead and put x. And we're done. We factored it. Not too bad. Much easier when you just have that positive 1 coefficient for the first squared term. So let's go ahead and try the next two. If you feel free to try them by yourself and see how well you do it. Okay, so once again, let's go ahead, set up our parentheses. The last term is a positive. So how would you get two positives? You can either do negative times a negative or positive times a positive. But since the middle term is going to end up being a positive, we know we're going to stick with a positive and a positive. Okay, next thing we're going to do is look at the factors of 32. So 32 factors into 1 and 32, 2 and 16. Let's see, 3, no. 4, can 4 go into 32? Yes, it can. 4 can go into 32. 8 times, and then 5, no. 6, can 6 go into 32? No. 7, no. 8, how about 8? Well, 8 times 4, but we already did that, so we know we've repeated. So these are the factored terms. Now, the question we have here is, which ones can we add to get a positive 12? Well, 1 and 32 we cannot add to get 12. 2 and 16, no. How about 4 and 8? Can we add them and get 12? The answer is yes. So go ahead and 4 and 8, and then we'll go ahead and write in the W. And we're done. Now, here's a question. How would you know if you got the right answer? Well, you could go ahead and just FOIL it out and see if we have the right answer. Let's do that check work. Did we actually factor this correctly? Well, first times first, that's going to be W squared. First outside, so 8W inside, 4W, and last, 32. 8 plus 4 is 12, so W squared plus 12W plus 32. Is that what we had in the beginning? Yeah, so we did factor it correctly. Okay, and that's a way you can check to make sure you factored correctly. Just go ahead and multiply it back out. And let's take a look at the last one. So this last one, we have a subtraction sign by the 35, so we know in our two binomials, one's going to be a positive and one's going to be a negative because of that negative right there. And then, what are we looking for? Factors of 35. Well, 1 and 35, 2, no. 3, no. 4, no. 5, yes, 5 can go into 35. 5 times 7. Can 6 go into 35? No. How about 7? Yeah, 7 times 5. But we just repeated 5 and 7, so nope, we're done. We only have two factors for 35. What am I trying to find? I want to be able to subtract to end up with a 2t. A positive 2t. Well, 1 and 35, if I subtracted those, I'd get 34, so that doesn't work. The only option I have is 5 and 7. Can I subtract those and get a 2? The answer is yes. The next question is, which one should be the positive and which one should be the negative? Well, since I want a positive 2, I'll go ahead and give the positive to the 7 and the 5 the negative, and then we just go ahead and write the first term for the t. And we're done. And once again, you could go ahead and multiply that out to make sure you'd factored correctly. So that was pretty straightforward. But now, let's take a look at factoring when the second degree term is not positive. So see that right there? That 3? That's a game changer. Our plan is going to change a little bit. Still a very similar plan, but we have to take into account that 3. So let's go ahead and set up our binomials for the factoring. Since we have a positive there, we know they're either going to both be positives or both be negatives. But since that 7 is positive, we know they should both be positives. So go ahead and do positives. Alright, so the way we do this, when we have a number by the x squared, you're going to take the factors from the first number, so 3, and then take the factors of the second number, 2. What are the factors of 3? Just 1 and 3. What are the factors of 2? Just 1 and 2. And now what we want is we're going to pick one factor from each group. Well, we're sort of lucky here. There is only one factor from each group. And we're going to do some testing. Okay, so we'll go ahead and put the 1 and the 3 and the 1 and the 2. Now we have two ways to test. We can do crossways, or we can do top and bottom. Let's test crossways. So if I test crossways, that'll be 1 times 3, which is 3, and 2 times 1, which is 2. Now what am I trying to find? I want to be able to add the products, add to get 7. Can 3 and 2 equal 7? No, that doesn't work. Okay, so the cross method didn't work. We have one other option. And if that fails, then we can't factor it, and it's prime. We can multiply top ways. So 1 times 1 is 1, and 3 times 2 is 6. Can I add to get 7? Yeah, 1 plus 6 is 7. All right, so we're going to go ahead and fill in our binomial, but we have to be careful here. Remember, the 3 was an x, so we have a 3x and a 1x. And this is saying that the 3 needs to be multiplied to the 2. So if I have 3x here, and I always start my x terms in the front. So 3x is here. If I'm talking about the O and I product, remember the O and I product I was talking about earlier? That's what we're going to be thinking about. So the 3 is part of the O product, so it should be the outside. So I'll put the 2 for the outside, and then I'll go ahead and put the other guys for the inside. Now, a lot of this still does take some educated guessing. So I want to have an x in each binomial, which means the 1x should be here, and the 1 should be there. And then, to make sure we actually factored this correctly, let's go ahead and FOIL it out. So the first term times the first term, that'll be 3x squared. Outside, that'll be 6x. Inside, that'll be x, and outside, lastly, 1 times 2 is 2. Adding these two together, we'll get 3x squared plus 7x plus 2. Is that what we had in the beginning? Yes, okay, so we did factor it correctly. Give yourself a pat on the back. Okay, and that's just a way to check. Alrighty. Let me go ahead and real quickly write this out. Factoring. So when you do the testing and factoring, make sure to label your factoring and then label your testing. So now let's take a look at the next one. We have 6r squared plus 13r minus 5. Now we're going to go ahead and set up our little binomials. But notice our last term has a negative. So one of these needs to be positive and the other one needs to be a negative. Alright, so let's go ahead and do our factoring. We'll take our first term, which is a 6, and factor that. That's 1 times 6, and then, 2 times 3. And those are the only factors. So let's go ahead and take the 5. The 5 can factor into 1 times 5, and that's it, because 5 is prime. Okay, so we factored everything. Let's go ahead and move on to the testing. This is where we take one pair from each group. So notice the 6 now has 2 pairs, so we have more to test, technically. So I'm going to go ahead and I'll pick 2 and 3 and 1 and 5 to test this time. So I have 2 and 3 and 1 and 5. Now remember, there are 2 different ways to do the testing. Cross and top and bottom. Let's go ahead and do the cross first. So we have 3 times 1, which is 3, and 5 times 2, which is 10. And what is my thing that we're trying to figure out here? We want to subtract, because we have a subtract to get 13. Can we subtract these to get 13? Now you might be tempted to say, yes, look, 3 and 10, that's 13. But the problem is we need to subtract because we have that minus sign. So these guys don't work. Got to be very careful on the signs. So even though you could add them, we can't subtract them when we're trying to do the subtraction. Once again, based off the sign of the last one. So let's try crossways. We have 5 and 3. Multiplying that, that's 15. And 2 and 1, that is 2. Can we subtract 2 and 15 to get 13? The answer is yes, we can. So we can subtract. The question is we want to end up with a positive 13. And to do that, that means the 2 needs to be the negative and the 15 is the positive. Okay, so real quick though. If these guys hadn't worked out, what would we had to do? Well, we would have had to group up the next terms, 1 and 6, and then 1 and 5, and done the same testing to see if we had an answer. And if none of these worked out, I would have had to write the answer of prime. Does not factor. So if your trinomial ever does not factor, right prime. Okay, but lucky enough for us, we don't have to get to that point. We have found our answer, the -2 and the 15. The next question is, how do we plug them in to our binomial? This is oftentimes your students do have a little bit of trouble, but just guess and check. Okay, so we know that the 2 and the 3 were from R, and the negative is with the 2, so these two are the negatives, 2R and 1. So I'll go ahead and put the 2R here, because that outer term matches with here, so we'll have that negative. And then we have the 3R, so I'll go ahead and plop the 3R here for the inside term and the 5. Okay, let's go ahead and check if our work is correct. So multiply the first two, that's 6R squared, outside, -2R, inside, 15R, last, -5. Adding those together, we get a positive 13. 6R squared plus 13R minus 5. And that is right, so we factored it correctly. Awesome. It's always nice to factor things out correctly. And if you didn't factor it correctly, well, you just go right back to the drawing board and check. The signs are usually where things go wrong, so always watch your signs. Okay, so we did factor it correctly. Let's go ahead and box our answer. And that is it for this section. Please, once again, if you need any help with any of these, either email me to set up a time to go over these, or drop by my office hours. And once again, the times for the office hours are posted on La Lima, or just send me an email asking about the office hour times.